Hello, welcome to another maths problem. Today we're dealing with moment of area. We are given a question says calculate the second moment of area for the area enclosed between the curve y square and x. The line x goes with respect to the x-axis and the y-axis. So we'll be using this equation. So this means rotate it about the x-axis, and then as you can see, the strip, it's in the x-axis. The strip as well here, it's in the x-axis. So first of all, we have to make the equation y the subject of the formula and draw the equation. So if you are not familiar with drawing the equation, you have to keep on checking on this channel. There will be some videos for drawing the equations. So I have something like this, making y the subject of the formula. Then from here to draw this kind of equation, it's like this. This is a half of a parabola, so I have to know how to draw this half of a parabola like this. And then drawing the half of the parabola, it's like this, and then draw the y-axis and the x-axis this side. And then they said it's the line x goes to 3. You'll have to write 3 here, 0 here. Then you will draw your strip. This will be a dx, the dx. So solving this one, calculate. Okay, this is already been drawn. So if you're not sure how to draw this equation, just arise from this one. It's the same as, it's similar to this one. If you know how to draw this equation, you can draw it like this. This is the equation for this one, and then this one is just a half, so it's in the x-axis, just a reminder. So the original equation for parabola, which I can say it's like this. So the other thing, it's a transformation. If they add plus, so it passes on the x goes to 0, y goes to 0. It's like this, the original. So the other one goes different direction if they add plus bx or plus c, so it goes like that. So if you'll see other videos like this, and that's okay. Let's get started. So the equation is this one. They say it's in the x-axis, so we'll pick this equation and write it like x-axis 1/3, and then the integral, it's ab, the limits. So the equation is like and then from here we'll substitute the value of y here, so we'll have something like, and our limit is 0 to 3 because the steps goes with the value of the x-axis. So the value of x-axis is have to be in the x. Our limit must be in the x because our strip is in the x. If it was dy here, we will take the limits of the y. Okay, substituting the equation, you have something like this. And then we have something like this, 1 over 3. And then we have x as 3 over 2. Then integrating this one, and then our limit is 0 and 3. Then substituting the value of 3 here, this is 5, not 3. And the other one, it will be 0. If we substitute 0, everything will be 0 here. Negative. So we have something like this. Then when you calculate everything here using the calculator, it's like 3 raised to 2,5 and divide by 2,5 is 6,23. So this is the answer, is 2,078. 2,078. So this is how we will calculate the x-axis using the moment of area. If we are given this, this is the y-axis and this is the x-axis. And then let's check the next one. This one said in the y-axis, so we'll use this equation. So if we are not with the equations, so we have to check on the formula sheet and the textbook, compare them before you go to write the exam, because they are not the same sometimes. I'm not sure, but I remember it's not the same as the way they write it. Check your previous question paper with your textbook if they correspond. Some of them, they are not the same, like for the volume and other, I think they are not the same. Try to compare them and see if you can remember how will you deal with them in the exam. Okay, let's get to the next one. So we're using this means it rotated about the x-axis, and then the strip does not change because it's rotated about the x-axis. Is the same graph that draw like this. This means this graph tells us that it's a half of what, of a parabola. So we'll write the half of a parabola in the x-axis. So it's the positive one. So we'll have a strip like this, and the limit is 3, and then your strip will be here, dx. And then this is the y-axis and the x-axis, and this is the strip. This is the strip. This is the strip. And then let's get into okay, we're doing this quickly. So we have a and b as our limit according to the equation dx, and then substituting the value of y, and our limit is 0 and 3. We take 0 and 3 because the strip tells us that our limit must be in the x-axis, because the strip is in the x-axis. So You'll take the limits on the x-axis because our strip is in the x-axis. So if it was dy, we'll take the limits of dy. The limits are interval 0 and 3, or the boundaries that are looking at the area. So you can see this is like an equation of area. This y dx equation. So this one is the distance squared, as you can see. So let's get into it. So we'll substitute the value of y, which is the square root of x. So we put the square root of x, and then continuing with this one, we'll have something like 0 and 3, and then we have something like, adding this 2, we'll have like 5. It's like adding a half on a 2, so it's the same as, and then integrating this one, you have something like 7 over 2 divided by 7 over 2, 0 and 3. So substituting those values, you have something like 7 over 2 is the same as 3, 5 over 3, 5. And then substituting the 0 part, it will be 0 when you put 0 there. And then let's check the using a calculator. So we have something like 3 raised to 3, 5 divided by 3, 5 is 13,361. So our final answer is 13,61. Okay, units. So we have something like this as our moment of error. So this is how you will calculate the moment of error. So if you like this video, for more you can subscribe, like and comment. See you on the next video.